So block diagram. A block diagram is used to represent a system. So it could be parallel, linear, or maybe a network of a network or a system of networks. So just like with the previous examples, we have here the system, which is divided into two, which is the H1 of S and the H2 of S. And this is our input, X of S, and Y of S is our output. Basically, these two elements here in the input should be added since there is a plus sign here. So from the frequency domain to time domain, we use convolution. So a convolution, the operation of a convolution is just multiplication, but it is denoted as asterisk. So actually asterisk is multiplication and addition. So to convolute this block diagram, we have here the output, y of t. We are dealing with the t domain, so we transform it, is equivalent to the input, x of t. We transform it from y of s to x of t, convoluted to h of 1 plus since we have plus here, the input again, x of t convoluted to h sub of 2 of s. So here, basically we just add this first term and the second. Let's use a brighter pen. This h of 1 is the part here, and the h of 2 is the lower part. But since we have plus sign here, we are going to add it up. So the output becomes, if we group it, x of t convoluted to h of 1t plus h of 2t. And this h of 1t plus h of 2t would be represented as h of t. And then plugging back into the equation, we have here y of t is equivalent to x of t convoluted to h of t. Basically, that is just the convolution. And here we have the S representation, or in the frequency domain of this block diagram. So just like what we did in the convolution, the only difference here is that it is in S, in frequency domain. The notation is in frequency domain. Thus, our elements here are the y and x are in capital letters. And instead of using convolution, we just use the basic, which is multiplication. So y of s, the output, is equivalent to x of s input, the upper part, h of 1s, plus x of s input again, multiplied by h of 2s. And then simplifying it, so we have here x of s multiplied by h of 1s plus h of 2s, and just like what we did in the convolution, we represent it with, simply represented by h of s. So that our equation becomes y of s equal to h of s multiplied by x of s. So in the S representation, or in the frequency domain, we could use or we could represent the transfer function. We could get the transfer function, which is basically the ratio of the output and the input. So here again we have an example of a block diagram with a feedback. So if feedback is basically a loop, there is a return of the output. So to convolute this, before doing that, I just have to emphasize that for this junction, this part of junction, we will denote it as E of t. So to convolute it, we have the y of t, transform y of s to y of t. Output is equivalent to h of 1t, this is 1, h of 1t convolute by E of t. And then E of t here represents the feedback. So basically the E of t is the x of s, or x of t rather. I mistaken this, so h of x of t plus the y of t, the output y of t, multiplied by the h of 2t here, since we have a loop. We have a loop here, or a what we call feedback. So this is the equation, simply as simple as that. So in the S representation, I already told it that it is the same with the convolution. It's just that the it is in S domain or in the frequency domain, and the operation is simply multiplication. So the output again is y of s is equivalent to h of 1 multiplied by x of s plus y of s times h2 of s, and then transposing this part y of s h of 2 multiplied by h of 1 to the other side, so that we could isolate, so that we could group it with 1 and take out the y of s, so we could get the transfer function. We have here 1 minus h of 1s h of 2s quantity multiplied by y of s is equivalent to h of 1s times x of s. And again, to get the transfer function, it's just basically the output of the ratio of the output and the input. So we have here, by multiplying this equation by 1 over 1 minus h of 1s times h of 2s, we have here the h of s as h of 1s over 1 minus h2 of s times h of 1s. So that is a block diagram with a feedback.